Hey guys, so before you continue, like and subscribe. Oh yeah. So before we start the video, I would just like to note you guys that Jeremiah's visiting all his friends back at school. Well, not really visiting. He's gonna be there for the last time at school. Then he's gonna go to a new high school. And so am I. And Jerry, Mikey, John, and whoever comes there as well. And we even have a Luigi, Goku, Vegeta, and those other people going there. That's crazy. So, before we get started with the video, oh yeah, guys, I'm talking here. I just like to know you guys that I'm doing this. So that way, I'm talking. Yep. So I'm gonna get my sketch coming. I think my sketch is coming this September. So is Ron's. Yeah, I know Ron's like this guy, but he's less calmer than my friend. He's one of Jeremiah's friends too. So let's begin day. Hey, we didn't do this in a while. What day was it? Day 27. Oh, day 27. Let's get in day 27. Jeremiah channel. Whoa? What's up, guys? Day. It's me, Mr. Wine. Day. We got this new class here. Alright. Let's go. This is crazy. Yeah, I know. Look at all these people. Yeah, it's such a big class. What's up, guys? Day. It's me, Mr. Wine. Day. We are gonna be learning something new. So as for my last two classes that I had, some of y'all may be in both of those classes, if that's even a chance. Or some of y'all may just be from the last class. And yep, so school is back, so yeah, that's why we're doing this. So why did we not record in a while? Because yeah, we were trying to think of what to do. So that's why. Okay, yep, so there's only 10 slides today, but they may be time worth it. They may cost lots of time. They may be time costing. You guys okay? Yeah. You guys gotta move over. Y'all are so big that y'all like cover. Y'all can take like y'all sales take like $2, bro. What's up? Yep. So we're doing this sugar. We're doing this sugar tea property. If that's how you say it, you guys. Yeah. You guys can correct me if I'm wrong in the comments. Today we are learning to do something new called distributed property. Oh yeah, I said that correct. Yeah, Mr. Wyman, you can take over now. Okay, Jeremiah. So in our lesson today, we were discussing on how to learn to do distributed property, how to deal with it, how to solve different problems using the property, and how to use it in some word problems. Let's get started. Yep, so I added a learning tip for all of our classes now. So that way, we're gonna focus on what we should be doing, how we should be doing it, and how we can master it. Okay, let's go. Oh yeah. Oh, yeah. Oh yeah. Yep. So by by the end of Mr. Lyon's class, I will be able to solve problems using distributed property. Use parentheses while doing the property. Add x and a random number and multiply it based on the problem. Understand very carefully and read thoroughly. And make sure I can master the distributive property and get quiz and get a great score on day 31 in school. Yep, so apparently it says day 33 there. That was in print. Don't worry, we're gonna change that. Yep, so here are some warm-up problems. So I'm gonna make some index cards and period, and maybe y'all will get a shot at it. Okay, let's go. Let's do this. Okay, so after Jeremiah got the stuff, we are now going to start. Oh yeah, you guys concentrate. You got, so 4 pencils, 8 cards. You can write this on your book. So, the first question is, whoever, okay, I'm gonna go with the easy one. Let's do the Wine Master. Okay. You can call me Wine Master. Okay. Let's go. Do I have to write that down? Yep. And you give it to me and I'll grade it. Well, once you guys leave. Oh, this is crazy. It's going good. Yeah, wow. Yeah, we just wait for him to solve that. Now you give that to me. Okay. Is that correct? Yep, that is correct. Let's freaking go. Alright, next problem. Ronnie. Really? How? You just go, man. It's not that serious. Whatever. I thought you were cool teacher. What? What are you freaking talking about? I write your silly problem down. I don't think that's not serious. Wow, you messed me up, huh? Let's see how it is. We could have paused the video, though. Oh yeah, by the way, you guys, this is not gonna be scheduled. We're gonna do that to our other videos. My answer is 30 plus 15x. You could have did 15x plus 30. There we go. Next, problem 3 is going to be. Oh, what? I see. Are you kidding me? Jeremiah just hit me with that. So you tell me we're doing the 7th grade now? Yeah, you guys are master right now. What? That's correct. Oh, yeah. Oh, yeah. Kill that. Be quiet, Trevor Marshall. Why you grab none when you eat? Like, problem 4 is going to Jerry. Alright, let's do this. Why would you just grab another one? Actually, we did. I don't know. This is definitely insane, bro. Why do I keep falling? Get back up. Hey, Ramsey, you better not say that. I'm done. That's correct? Yeah. What? You just do. Alright, problem 5. That's going to, let's do one of the girls here. Let's see. Yeah, before we do the girls, we're gonna do rapper. What? I was just chilling, bro. I'm not your bro. I'm completed then. We're already 10 minutes in this. Or 9 minutes. That's correct. Let's go. Now we're gonna do one of the girls here. You're gonna continue with you. Y'all lucky dude. Y'all know how to get this. I'm going to select. Why not button? Alright, I'll give it. I'm done. What's the answer? That is correct. Oh yeah. We're going to replay this video again. Make sure who did it. So that way you guys will get points based on your grade. Next up is, let's do Maddie. She hasn't been here for a while. Oh yeah, guys, these are the problems, by the way. So you guys can just pause now. I'm gonna show this for a few more seconds. And we're done. I got the answer. You got there? Yep, I got it. That is correct. Oh yeah. Now this one goes to. You do one of those superheroes back there. What? You can't do that. What? You can't do that. Go was Iron Man since he talked about me. What? I was just chilling. You talked back to me and you mocked me. I did not do that. Spider-Man, Batman, y'all next. What? We didn't say anything. Yeah, that's right. Instantly. Your insane gonna get me. Calm down, bro. I said I'm not your bro. Whoever calls me bro next, they're gonna get kicked out here. Or they're gonna go to the timeout area. That's what's gonna happen next. This guy is gonna get me in trouble. Bro. This guy. Yeah, I hate the curse. I hate the curse. This guy's getting too loud. That's correct. Let's go, man. That's it. About game time. You lucky you don't have to do another one of those. That would have made it like harder. Oh snap. Okay, y'all took like too long with that. Oh, shut up. Chase. Rescue Woods chase you next. Yeah, sure, buddy. I'm not. Whoever talks back to me trashfully will get. Yeah, they're gonna go to that timeout area, which is all in the bathroom. They can smell that bathroom floor. And I ain't gonna clean that up. Oh yeah. So I'm gonna ask three of you guys what distributed property is and how it's used in different problems. Yeah, I ain't gonna do that part. I'm just gonna ask three of y'all. I'm only gonna ask like one of you guys. After we do that, we're gonna watch a video. Then we're gonna watch another one at the end. Why are we watching two videos? I don't know. Okay, so let's do one of the bottles. Let's do the quietest one. We're gonna do a brown bear. Oh, what, me? Wait, I already did prom. Oh yeah, you did. Let's go with Mr. Aaron. Bro looks like he got burnt on the sea. I did not get burnt. Whatever. Mr. Aaron, coming up. Explain to the class what distributive property is. You're not even saying it correctly. You will? Oh, whoops, I'm sorry. Yep, so the distributive property is where it's like shown there, where there's like a number you put out the percentages, and where there's an X. Yeah, there's an X. You always add your X. That's the variable. And then you either do plus or negative, and you just add a number like that too. And then you just multiply the X and number by the number outside there. And then you get 5x and plus 10. Thanks for the background, idiot. I'm not your idiot. Ow. Yo, watch it. Good job, Mr. M. You lucky you gave a good presentation on that. For that joke you just made about me. I swear, this class is the worst out of my other two. I wish you guys did my darn work. Okay, so we're gonna watch a video, so y'all need to listen up right now.
Welcome to Math with Mr. J.
Why is it 8 minutes?
In this video,
So y'all can handle 8 minutes.
simplifying algebraic expressions.
Y'all need to listen to Mr. J. And y'all talk, y'all getting kicked out here. Do y'all hear me? Yeah, we hear you. Yep. I gotta restart this again. Since I was talking while this guy was teaching. Weren't you teaching?
Welcome to Math with Mr. J.
You gotta be quiet. Yeah.
In this video, I'm going to go through an introduction.
There we go. We did it full screen.
Algebraic expressions using the distributive property. Now, the distributive property can help us remove parentheses within algebraic expressions. This helps us simplify expressions.
Can y'all hear it?
Like terms within parentheses that we
Okay.
can combine. Now remember, when we have something next to parentheses, that means multiplication. So we can use the distributive property to distribute whatever is on the outside of the parentheses to the terms inside inside the parentheses. The distributive property works when we have addition or subtraction inside of the parentheses. So at the top of the screen, there is a general overview of the distributive property where A is being distributed to the
This is
terms
lame.
inside of the parentheses.
Shut up,
The
Batman.
distributive
You gets
property
killed.
and that overview will
I
make a
ain't
lot
gonna do
more
nothing, bro.
sense as we go through our
Yeah,
examples.
right.
Let's jump into
Hey, I hear
one
y'all
where
talking
we
about
have
there.
2 and then in parentheses 5 plus 3. And we're going to do this 2 different ways by using the order of operations, so doing what's in the parentheses first, and then also using the distributive property. Now for number 1, we don't have any variables involved. We are actually able to add what's in the parentheses
Mr. Lyon, you have a
first
question?
and then go from there.
What's the
We don't
question,
have to
boys?
use the distributive property, but the
Dude, we
point
gotta
of
listen
number
to this
1
guy.
is to show us
Yeah,
that
you
we
guys
get
have
the
to listen
same
to it.
thing either way. This is going
Oh,
to
okay.
show us that the distributive property doesn't change the value of an
Oh, I have another
expression. We
question.
are able
What's the
to
question?
use this strategy. So again,
Why
we get
does it
the
say
same
A, B,
thing
and
either way.
mine is
Let's
AC?
start by using the order
Why
of
does it have-
operations and doing
why
what's
does it
in the
include
parentheses
B?
first.
Why does
We
it
have
include A,
5
B, and
plus
Z?
3,
That's how the guy
which
teaches.
is 8. Bring down the 2. And now we have 2 times 8, which is 16.
Then my kid.
Now let's use the distributive
Y'all need to be quiet.
property
Y'all
and
gonna
see
throw
if we
the
still get
the
16.
quiz, you
So
know?
we need to take that 2 on the outside
And
of
this
the
quiz has
parentheses
30 questions. 30 questions? Are you freaking
distribute it
serious?
to the 5
Watch your mouth,
and
JP.
to the 3. So we
Yes,
have
it has 30 questions.
2 times 5 plus
So how much do we need to pass?
times
Y'all
3.
need 21
2
out of
times
7.
5
Y'all need 21 out of 30 to
gives
pass.
us 10 plus 2 times 3
Really?
gives us 6.
Yeah.
10 plus 6 is 16. So we get 16 that way as well. So we can see that the distributive property doesn't change the value of an expression, and we are able to use it. Let's move on to number 2, where we will apply this to an algebraic expression. In order to simplify the expression, we are going to remove the parentheses. For number 2, we have 8, and then in parentheses, 2m plus 6. Now we can't combine those terms in the parentheses, so what we can do, we can use the distributive property to remove those parentheses and simplify this expression. So let's distribute the 8 to the 2m and to the 6. This gives us 8 times 2m plus 8 times 6. 8 times 2m
This is boring.
is 16m plus
Don't worry,
8
we're
times
going to
6
the fun stuff soon.
is 48. Now 16m and 48 are
Yo, did you
unlike
guys
terms,
hear
so
that
we
they're
don't
gonna
have
have a
any
fun
terms
fair?
that we can
Day
combine.
35 in
So
school.
we are
That's like 8
done
days
here.
away, bro.
16m
Yeah, I
plus
know.
48 is our simplified expression. Let's move on
Did
to
I
number
have
3, where we
food,
have
snacks, and pizza
7,
and all
and then
that
in
stuff?
parentheses, a minus 9.
Yeah, I did.
Let's distribute that 7 to the a
Okay, that's good.
and to
Alright.
the 9. That gives us
I hear
7
y'all talking right there.
times a minus, bring the subtraction sign down, 7 times 9. 7 times a is just 7a
What you gonna do after this, bro?
minus 7 times 9
I'm not sure.
is 63. So we end up with 7a
Well,
minus
I'm definitely
63.
doing
We
all
don't
homework,
have any
that's
like
for sure.
terms that we can combine.
Yeah, sure.
So we are simplified and done. Again,
You guys can't be
7a
talking.
minus 63.
Be quiet.
Now I do want to mention
Be quiet,
another way to
one-legged
think
boy.
through this, and this is
Yeah.
another way to think
Very
through
funny.
whenever subtraction or negatives are involved. So let me rewrite
I'm watching
the
y'all.
expression.
I'm watching
And
y'all
then
like some.
distribute.
I'm watching y'all like an eagle.
The 7.
You know. I'm watching
So
y'all
we have
like an
7
owl.
times a, which is 7a, and then we can think of that subtraction sign and the 9 as a negative 9. So including the sign in front with the 9. So we think of that as a negative 9. So let's distribute that 7 to the negative 9. 7 times negative 9 is negative 63. So negative 63. And we get 7a
Excuse me, when was
minus
the video?
63
2
but you
minutes.
can include the sign in front of the term and think of that as a negative 9. So something to keep in mind. Let's move on to
This
number
is
4, where we have 10 and then
I
in
said it would be
parentheses,
quiet.
negative 5x minus 4y. Let's distribute the 10 to the negative 5x and to the 4y. So 10 times negative 5x minus 10 times 4y. 10 times negative 5x gives us negative 50x minus 10 times
It doesn't sound
4y gives us 40y. So we end up with negative 50x minus 40y. Don't have
You
any
still have that hat after last year, Dolphin?
So we are
I do.
done. Again, negative 50x minus 40y.
No, that was me, bro.
Now let's take a look at a different way to think through this. So I will
Yeah,
rewrite.
okay. If so, after you did all the problems, if so, when you guys get to tell me about what that video was about, and everybody, well, most of y'all is answering today. So let's go with Chase. Okay, so the video was about Mr. J teaching us on how to do the distributed property in different ways. In 2 different ways or 3 different ways. I'm not sure how he did it. But he did the problems and explained to us on how to do it using the property and how. I guess that's it. How what? And I guess how he did it correctly. And he's showing others on how to do the problem in different ways. When there was different variables there. Okay, I'll take that. Let's go. Here are some word problems. Dang, that's all I tell. Alright, number 1. Jeremiah Reed. Carter picks out different fruits to add into his fruit salad. X is the number of apples in the basket that he brings out. Oh yeah, this is nothing like the work that Mr. J did on there. Yeah. I'll just tell you guys now. If there was 6 apples in each basket and 12 strawberries in the ground, how much baskets would Carter need if we had 30 pieces of fruit? Let's go with Spider-Man. Okay. I can see that. I like how it's different color. Yeah, I can't even see the brown bird. I cannot see that brown. Okay, so 30 minus 12 is 18, and 18 divided by 16. So the answer is B, 3 baskets. That's correct. Let's go. Number 2. Charlie has different kinds of cookies that she and her friend Molly brought at a sleepover. Charlie brought 45 cookies. Damn, that's a lot of cookies. Who you feeding? Cookie Monster? Be quiet, somebody. That was kind of funny. Be quiet. What do you mean be quiet? The chocolate chip cookie had 3 times more than the lemon cookies, which only has 7 cookies though. So there's 7 lemon cookies. So that means there should be 21 chocolate chip cookies. I'm giving y'all hints. Y'all should listen. Sugar cookies is X. Had 8 times more than chocolate chip cookies. I'm not sure why I said 8 times more. Yeah, so basically just put 3 times 8. Yeah, just put 3 times 8. And then chocolate chip cookies. How much sugar cookies were there? A, 19 cookies. B, 21 cookies. C, 24 cookies. Or D, 16 cookies. Let's go with Susie. Alright, now go. I think everyone's answering for me. Can I go up there? Yeah. Z, bro. That's my color. C? Is it C? That's correct. Oh yeah, let's go. That was lucky. That was not lucky. Yeah, she's right. Number 3, Jack took pictures of 56 animals at a zoo. That's a lot. Half of the animals were lions, which is me, zebras, A, and gorillas. A quarter of the animals were cheetahs, frogs, A, it's B. Oh yeah, Froggy's not in this class. Why do you say it like that, Ricky? Awesome? Wait, what? Froggies and monkeys. Hey, that's my brother. What do you mean? The rest X, which is X, were ostriches, giraffes, and parrots. Speaking of parrots, where is Pirate right now? He's not in this class. How much animals is in the X category? A, 28, B, 14, C, 21, or D, 42? Let's go with orange. Let's go with orange balloon. He looks like a freaking flying balloon. Be quiet, Chase. You're so mean. I know. So, the answer is B, 14. That's correct. Oh yeah. Okay, number 4. Sammy and her friends went to a skateboard trick contest in order to compete in the tournament. They did 105 tricks altogether. No way. Seriously? Yeah, that's not even possible. Or is that like just basically dirt in the park? So Sammy did 4 times more than the tricks than her friends did. She has 3 friends. Just tell you. How much trick is X? How much trick does Sammy do? A, 60, B, 60, yeah. And the number, so basically it's the number out there, 66, that's for B. C, 64, or D, 63? Let's go with it. Oh, what? How do you just fall like that? Clumsy? I'm not clumsy. How do you just fall? Batman. Let's go. The answer is 6. Nope. 6. Wait, I'm confused. Oh, it's C. That's incorrect. What? You gotta be kidding. That's incorrect. No. No way, bro. Let's go with. Monkey sister. The answer is A. That's correct. Oh, right. Let's go. I didn't even know it was A, bro. You're a loser. After doing the word problems, we will watch a 12-minute video. 12 minutes? You gotta be cute. We should watch 20 minutes of all videos. When distributed properly, during some parts of the video, some tools will be called on to answer the questions shown on the screen. If you get it correct, you will get a custom award for any of your teachers on the 29 days of school. Ooh, custom awards. I kind of want that. Me too. Let's go. Same. Yeah. Watching a video. Math answer.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to talk about the distributive property, which is a really useful tool in algebra. And if you watched our video called the distributive property in
Mr.
arithmetic,
Wine, why are we watching?
basics of how the
Why are we
distributive property
watching
works.
2 videos of
The
the
key
distributive
idea
property?
is that the distributive property
So,
allows you to take
instead
a
of a
factor
game, you guys
and
are going to
distribute it
watch a
to
video.
each member of a group of things that are being added or
Don't
subtracted.
worry, the next time you guys
Instead
come
of
here,
multiplying the factor by the entire group as a
y'all will do the
whole,
quiz.
you can distribute it to be multiplied by each
Then
member of the
whoever's
group
done with that,
individually. And it,
okay, so, after, yes, when you guys come back in the 31 day of school, y'all will have that math quiz. So that way you guys should learn what's in the field. Right there. Yep, so I'm gonna call on you guys. Well, a few of you guys that haven't answered yet. Is it yet that way? If you're done early,
algebra involves unknown values.
if you're
variables,
done
right?
early,
So So in algebra,
You can,
might
like,
have an expression
yeah.
like this. 3 times
If
the
you're
group, x
done
plus
early,
6.
you can go downstairs.
In this
and
expression,
no.
we don't know what
You
value
can stand
x
here.
is. It could
You
be
can
4,
watch-
like in the
watch
last expression,
TV.
but it doesn't have to be. It could be
Then
any
watch
number
some
at all.
stuff here and
And
then
since
play
we don't
games.
know what it is, that means we
Play
can't
games,
simplify
sure.
the group first in this case.
Alright,
Our
man.
only option here
Let's go.
is to either leave the expression just like it is,
See
not
when they
simplify it
want
at all,
that, huh?
or use the distributive property to eliminate
Y'all
the
need to
group.
be quiet.
Just like in the arithmetic video, we can distribute a copy of the 3 times to each member of the
Dude.
group. So the group goes away and we end up with 3 times x plus 3 times 6. The 3 times x can't be simplified any further because we still don't know
That's
what x
3x.
is. So we can simplify 3 times 6 and just write 18. So the distributive
Yeah,
form of this expression
phone.
is 3x plus 18.
3x plus
And even
18.
though we can't simplify these expressions all the way
Okay,
down
yeah,
to a
that
single
doesn't
numeric
count,
answer without knowing the value of x, we do know that these 2 forms of the expression are equivalent because they follow the distributive property. So the distributive property works exactly the same way whether you're working with numbers or variables. In fact, in algebra, you'll often see the distributive property shown like this. A times the group B plus C equals AB plus AC. Or you might see it with different letters like X, Y, and Z, but the pattern will be the same. This pattern is just telling you that these 2 forms are equivalent. In the first form, the factor A is being multiplied by the entire group. But in the second form, the factor A has been distributed, so it's being multiplied by each member of the group individually. And if you're looking at this thinking, what multiplication? Remember that multiplication is the default operation, which is why we don't have to show it in this pattern. Since the A is right next to the group, it means that it's being multiplied by the group. And on the other side, since the copies of the A are right next to the B and C, it means they're being multiplied also. And even though this pattern is usually shown with addition in the group, remember that it also works for subtraction, since subtraction is the same as negative addition. But the distributive property does not apply to group members that are being multiplied or divided. Okay, so this is the basic pattern of the distributive property. It's usually just shown with 2 members in the group, but remember that it works for groups of any size. We could have A times the group B plus C plus D, and the equivalent distributive form would be AB plus AC plus AD. Here's a few quick examples that have a combination of numbers and variables to help you see the patterns of the distributive property. 2 times the group x plus y plus z can be changed into the distributive form 2x plus 2y plus 2z. 10 times the group a minus b plus 4 can be changed into the distributed form 10a minus 10b plus 10 times 4, which is 40. And a times the group x minus y plus 2 can be changed into the
No, whoops. No, whoops, you're right back. I just sold that. After the error, we're back.
Realizing that these groups of things
We
being
can
added
get
or
into
subtracted
questions,
are really just polynomials will help you see why the distributive property is so useful in algebra. For example, in this simple expression, 2 times the group x plus y, the x and the y are simple terms in the polynomial x plus y. Each of the terms has a variable part, but no number part. And if we apply the distributive property to the group, we get the equivalent form 2x plus 2y. But what if the polynomial was just a little bit more complicated, like this? 2 times the group 3x plus 5y. In this expression, each of the terms in the polynomial...
Okay, guys, so what is the answer to this solution? Alright, Dolphin, you can answer it. Okay, so it's 6x plus 10y. That is correct?
does have a number
Let's go.
that is being multiplied by the
That
variable.
was kind of easy.
But we can still use the distributive property to distribute a copy of the factor 2 to each term in the polynomial. Wait just a second here. I noticed earlier
he has
that you said that
clones?
the distributive property does not work with members of a group that are being multiplied. And I also noticed that these terms do have multiplication. What's up with that? That's a good question. And it can be a little confusing to see how it all works at
They
first.
just work the
But
same.
notice that even though the terms do have multiplication in them, the terms themselves are being added. So we distribute a copy of the factor 2 to each whole term, but not to each part of a term. In other words, we treat each term in a polynomial as an individual member of the group even if that term has multiplication going on inside of it, which is common since there's often a variable part and a number part being multiplied together. Getting back to our example, distributing the factor 2 to each term gives us 2 times 3x plus 2 times 5y. But this can be simplified even further because we know that 2 times 3 is just 6 and 2 times 5 is just 10. So the distributed form is 6x plus 10y. Let's try another example of a factor times a polynomial. 4 times the group x squared plus 3x minus 5. First, we need to...
What is the answer to this? What is the answer to this, you guys? Let's go with... Who did answer? Oh yeah, let's go with Bullseye. Teacher, we never did it before. Don't worry, you guys can... Don't worry, you can do it. Wait, what? I don't get it. What are we supposed to do? Let's just wait until we answer that. Okay, I got my answer. The answer is 4x with the exponent 2 plus 12x minus 20. Dang, that was correct, man. That was a little hard.
Identify the terms of this polynomial, so when we distribute the factor, we just make one copy of it for each term. This polynomial has 3 terms, x squared, positive 3x, and negative 5. So we distribute a copy of the factor 4 to each term, and we get 4 times x squared, or just 4x squared, 4 times 3x, which is 12x, since 4 times 3 is 12, and 4 times the negative 5, which is negative 20. So the equivalent distributive form is 4x squared plus 12x minus 20.
That's correct.
Let's see another example. X times the group x squared minus 8x plus 2. In this expression, the factor...
Do you guys know the answer to this? Let's go with 0. Oh god, he was kidding. Yeah. Maybe I got the answer? Okay, so the answer is x with the x squared minus negative 8, minus 8 squared, negative 8 squared, and then plus 2, I'm not sure. Seems harder than you think, huh?
being multiplied by the group is actually a variable, but the distributive property works exactly the same way. And it says that we can distribute that factor and multiply it by each term of the group individually. The first term is x squared, which is the same as x times x. So if we multiply that by x, we'll get x cubed, since that would be 3 x's multiplied together. The next term is negative 8x. So if we multiply that by x, we'll have negative 8 times x, which is the same as negative 8x squared. Last of all, we have the term positive 2. And x times positive 2 is just 2x. So after distributing the factor x to each member of the original group, we have the polynomial x cubed minus 8x squared plus 2x.
That's crazy.
See why the distributive property is so handy in algebra? It shows us how to multiply a polynomial by a factor. We just distribute a copy of that factor in each of the polynomial's terms. So I know what you're thinking. If we can distribute something to each member of a group, can we do the process in reverse?
Ice cream.
Undistribute something?
Oh man.
We sure can. Take a look at this polynomial. 4x cubed plus 4x squared plus 4x. Notice that each term of this polynomial has a factor of 4 as its number part.
Okay guys, this is a challenge question. What is the answer? If you multiply 4x squared, that means you're going to multiply 4x squared 3 times, multiply plus 4x squared, multiply once, well twice, and then plus 4x. Let's go with, yeah, we're going to go with brown bear. We're going to go with, I think everyone knows. Well, let's go with Jerry. No, let's go with Koala. He didn't answer. I got the answer. It's 84x. That's correct. Let's freaking go.
It kind of looks like someone distributed a factor of 4 to each term. Since distributing a factor means making multiple copies of it for each member of a group, undistributing is going to mean consolidating multiple copies of a factor into a single copy that's multiplied by the whole group. So in this case, we can remove the factor of 4 that's being multiplied by each term individually, and then we can consolidate those into a single factor of 4 that's being multiplied by the entire polynomial by using parentheses to turn the polynomial into a group. But mathematicians usually don't call this undistributing a 4. Instead, they would say that we factored out a 4 from the polynomial. So you can use the distributive property both ways. If you get the expression A times the group B plus C, you can distribute a copy of the factor A to each member of the group. But if you're given the expression AB plus AC, you can apply the distributive property in reverse and factor out the A so that it's multiplied by the whole group at once. It's important to realize that neither of these changes the...
Yep, so basically, let's see if you guys can do these last two. Yep, so what is the answer? Yeah, it shows you guys the answer.
We remove the 2
I'm not sure
from
I
each
see.
term and consolidate it to form a... So that's the basics of how the Notice that when we do that to the last term, which was just A, that term becomes a 1, because there's always a factor of 1 being multiplied by...
Oh yeah, last question. What is the answer to this? We're going with... Yeah, let's go with Ramses. No! I got the answer. The answer is x cubed plus x squared plus, I guess, 1x. Or just 1a. That's correct. Let's go. Man, Mr. Wine, you weren't kidding. And you gonna give us those problems? Yeah, but I did that unsuspectedly. They would mostly be at the middle. Oh yeah, guys, that was the end of the slides on day 27. Like, hell, you still have that computer, man. Why do you look like y'all about to kiss each other? Rabbit and dog. We are not. I'm just tired, you know. You should be tired. You should have gotten some sleep. Y'all always do this in the afternoons and evenings. Oh yeah, you guys can be dismissed. And I'll see y'all in 4 days. Let's go. Finally out here. Yeah. If you guys enjoyed that video, make sure you guys subscribe. Well, the school video. Comment, share, and we'll see you guys next time. Bye. See ya. You too.